Hello. We're starting chapter 5.1 notes. Look on page 330 and you'll see a place value chart. Notice how it has changed since chapter 1. So here we go. In chapter 1, all we had was this part of our place value chart. Now, with this one, where this darker line is where your decimal goes. And notice there is no once. It's just starting at tenths, hundredths, thousandths, 10,000ths, and so on. So where your decimal goes is where the word and is usually placed at. Excuse me. Now notice there's a ones, then tens. Oh, and on the other side of ones, tenths, hundreds, hundredths, thousands, thousandths, 10,000ths, 10,000ths, etc. So, remember, there is no once. Now, I hope I didn't make you dizzy. But getting back to here, a decimal, the definition of that is just part of a whole. Now, to write 0.7 in words, you would say 7, and that first place value, what is it called? If you said tenths, you said it right. Then on B, negative 50. Now where the decimal goes is where the word and goes. Then we've got 8 tenths, 2 hundredths. So 8 and 2 would be called 80 dash 2. And then the 2 ended up in the hundredths place, so that would be 82 hundredths. Please forgive my crappy writing, but it's something we got to deal with. Then this part of this number is 21, and remember, if two digits in the tens and ones place are combined with two words, you have to have the hyphen in. Whoops, not two. If the two numbers in the tens and ones place have to require two names, then we have to combine them with the hyphen. Now again, where the decimal place goes is where the and goes, and then tens, hundreds, the 3 landed in thousands. So 90 dash 3, and then you would say thousandths. Yuck. Now, the golden Jubilee diamond is 545 carats, and then the 62 in decimal, they would call it 67 points. So here we go. 545 and then you would say 60 dash 7 and tens, hundreds, so hundredths. If you have any questions, just ask. Now, on page 332, I want us to look at examples 5 and 6, so get ready to be dizzy. Hold on. Right here. 48, so 40-8, then the and, so 4 and 8, and then a decimal, 26 hundredths. So what we do is we say tenths, hundredths, so there has to be 2 decimal places. So that's nice because there's only 2 digits. So 48 and then 26 hundredths. Now, on example 6, 6 and 95 thousandths. So we would put the 6, we would put a decimal, tenths, hundredths, thousandths. And then 95 is only 2 digits, so we have to put a 0 in front of the 9. Okay, if you have any questions, again, ask. Phew. Now, writing a decimal as a fraction. Well, I would like to take the 6 and 95 thousandths. The fraction part, we're going to use this. We would put only the 95, and then when we put a fraction bar and put a 1 under it. Now we have 1, 2, 3 decimal places. So 1, 2, 3 zeros. And a whole number will stay a whole number when you're writing a fraction. And actually, in this case, it's a mixed number. Now, on both the top and the bottom part of the fraction, I can divide them by 5. So 95 divided by 5, and I'm going to cheat and use a calculator. That gives us 19. Then 1000 divided by 5 gives us 200. Okay, I want to back up just for a second because I just noticed this little note here. Pay attention on how to write your checks on pages 331 and 332, because again, this is a big fat hairy deal. Where the decimal goes is where the and will go when you're writing it out. What is the unspoken rule of fractions? You always, 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 and forever have to reduce. The key here is this. The whole number stays the whole number, just like what I said right up here. Okay? So when we write these decimals as fractions, we take 31 over a 1. Then we have 2 decimal places, 2 zeros. And 31 is prime, and 31 does not go into 100, so that one is done. Then 47 over a 1, and we have 2 decimal places, 2 zeros. Again, 47 is prime, and therefore it doesn't go into 100, and we're done with that one. Now on this one, 51 over 1, but we've got 1, 2, 3, 0 decimal places, so 1, 2, 3 zeros. 51 isn't prime, but it does not go into 1,000, so we're done with that one. Now here, 5 is a whole number. It's going to stay a whole number. Then we put 6 over a 1, and we have 1 decimal place, so 1 0. Well, guess what? Both of these are even, so I can divide a 2 out of them. So that gives us 5 and then 3 fifths. And then number last, negative 29.95. Again, the negative 29 is the whole number. It stays a whole number. Then 95 over a 1 and 2 decimal places, so 2 zeros. Again, I can divide a 5 out of top and bottom, so that gives us negative 29. And just like with up here, 95 divided by 5 is 19. Then 100 divided by 5 is 20. when you are comparing two decimals, what you do is you line them up. 28.253, 28.2530. Now just because one of them has more decimal places does not mean that it happens to be bigger. Because as you see, if I replace empty places with a 0, these are exactly the same. So these are equal. And with negative numbers, you have to be careful, because with negative numbers, and let me adjust the camera a little bit here. With negative numbers, the bigger absolute number happens to be the smaller number, because think of a number line. As you go to the left, numbers get smaller. As you go to the right, they get bigger. So negative 1.224, negative 1.22301. Okay, these are the same, these are the same, these are the same, these are the same. Now with a negative number, remember, your bigger digit makes this number smaller. So this one happens to be bigger. Then 21.12321, 21.1233. The same, the same, the same, the same, the same. Oops. This one's bigger right here. So this one is the bigger number. Alright? And again, do the same thing here. 0.378, 0.3779. Just because this has more digits doesn't mean it's bigger. These are the same, these are the same. This is bigger. And then 0.052, 0.0520000, and if we wanted to, we could place those empty places, replace them with zeros. So same, 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 same. So these are equal. Even though they look different, they're still equal. So 0.026, 0.12, ooh, not the same. This one's bigger, so our sign goes that direction. Okay, I'm not going to write out my steps, so as we round these numbers, pay close attention to the clues I give you. Use this number, round it to the nearest, and in this case, tenth. So 736.2359 to the nearest 10. The nearest 10 is right there. Alright? The next number to the right is 5 or higher, which means that I knock that off, replace it with a 0, and I add 1 to the 3. So this makes it 740. Now round it to the nearest tenths. So 736.2359 to the nearest tenths is right there. So I look only at the next number to the right. It's a 3. It's less than 5. So all I do is I knock those numbers off. So that ends up being 736.2. Now to the nearest thousandths. So 736.2359. Okay, thousandths. So tenths, hundredths, thousandths. The number next to the right is 5 or higher, so I knock that off and I add 1 to my 5. So 736.236. Where is a place where we really use this in real life? Well, with money. You ever been to a gas station where it's $3.29.9? Well, they're kind of fooling you. Instead of saying it's $3.30, they're going to say this, but it's basically equal to that. Also, when you're doing groceries, when you get 6% sales tax on what you're buying, you're actually a lot of times going to get, let's say like the amount ended up $139.27.825. Well, you're actually going to pay $179.28. So this is a place where we actually use decimals and rounding in real life.